Let's do 6A part 2. So now we're on number 5. That's a 5. It looks like either a 6 or an 8, but it's a 5. Let's do number 5. So this is, again, what we just left off. If you didn't watch 6A part 1, make sure you do. Especially make sure you watch the problem I made up, because you probably will see it again on a test. Let's talk about, again, the median and the mean and why we would use one versus the other. So for these examples, again, remember it says in the directions for number 5 and 6, give an explanation of your choice, or for your choice, sorry. This will be super important on the test too. I haven't decided how I'm going to do the test yet. I guess I got to get on that since it's next week, but I will. I'll figure it out and I'll let you know. I want an explanation though. So for number 5, they ask us to tell whether the mean or the median seemed like a better way to describe the central tendency. I don't like that they write or average there. I might delete that on your worksheet. And give an explanation for your choice. So number 5, the age of first marriage of men in America. What do you think? Should we just average all the ages together? Or should we put them all in numerical order and pick out the middle one? What do you think? Which one's a better way to talk about it? If we want to know what is the quote-unquote normal age of getting married as a man in America. Well, if we leave all of the numbers in there, including people that get married very young or people that get married much older, it's going to skew the data. Probably it's going to skew it much older, right? People are still getting married in their 50s, 60s, maybe even 70s or 80s, but that could definitely skew the data older. You could get married when you're, 16 or 18, but that's not much younger than, I'm guessing the average age is somewhere probably in your late 20s or so. I don't know the answer. You could Google it, but I'm guessing. So, getting married at 16 wouldn't be that much younger, 10 years younger, but getting married at 60 would be much older, right? And it would skew the data that way. So I think for number 5, the better answer would be to use the median, because it removes the outliers, right, in number 5. So I'm saying median is the correct answer there. If you have a different answer, feel free to email it to me. I'll let you know what I think. For number 6, the number of pieces of lost luggage per flight from an airline company's perspective. What do you think? Well, if we use the median on this one, right, we're including zeros, right? Many flights are fine and they have no lost luggage, so we'll have a lot of zeros, right? But then on other flights, you have 1 or 2 pieces lost. If you use the median, it might actually end up equaling 0, because I feel like on most flights, most of the luggage is fine. Of course, you get on those flights where it's like everyone's luggage is lost. So if you were to use the median for this one, your answer might actually equal 0. But is that really representative of how many pieces of luggage get lost overall? Probably not, right? Because probably there's some number there. So what if you use the mean? It would also still include all those zeros, but then it would include those really big numbers too. So when you average that together to get the mean, you might get, a decimal. You might get 0.1 pieces of luggage lost per flight, right? Which logically doesn't make sense. You can't lose 1/10 of a piece of luggage per flight. That makes no sense. That's like saying, the average American family has 2.5 kids. Well, that doesn't make sense, but we know data-wise that it's probably somewhere between 2 and 3. So we would know if we use the mean for number 6 that on average they probably lose either no luggage or maybe a piece of luggage. But it's usually small. So number 6, I would say the mean is the more appropriate answer. What about 7 through 9? Let me check the camera and yawn. Sorry. All right. What about 7 through 9? They want us to complete the following. They want to know about the distribution. We'll talk about that, of course. Make a sketch of it. So basically, they just want to know what would the graph kind of look like. How many peaks would you expect? Okay, how many times does it form a peak? Would you expect it to be symmetric, left skewed, or right skewed? So let me just draw a random graph. Okay, this graph looks like this. It has one peak I would call this graph symmetric because if I drew a line down the middle, I could kind of fold this together, right? And about half the data is on either side. It doesn't skew left or right, it's just symmetric. If I wanted a graph that skewed left, my graph would look like this, maybe. Most of the data is on the left-hand side. If I wanted a graph that skewed right, it might look like this, right? Most of the graph is on the right-hand side, something like that. Symmetric means it pretty much cuts down the middle. Those all only had one peak. But let's talk about number 7. The weights of all people who use an ice rink, which is open to figure skaters in the morning and hockey players in the afternoon. What do you think this graph is going to look like? Well, we know they're probably coming in first thing in the morning and it probably, oops, I don't want to go that high because I know this one's going to probably be heavier, right? Goes like that, then they leave. Then the hockey players come in, right? More likely than not, they weigh more, right? Generally, there are more male hockey players than female, but even if they were both females or both males, what is true about hockey players? They wear a lot of gear, right? So no matter what, they're going to probably weigh a little bit more, right? So your peak here is going to be a little bit higher. What would you say about this graph overall? It has 2 peaks, right? Here and here. Is it left skewed or right skewed? It's right skewed, right? Most of the data, if I drew a line in the middle, most of the data is on this side. It's not a lot more, but still most of it. What about part D? Would you expect the variation in the distribution to be small, moderate, or large? Interesting question. What they want to know is the data under the graph all contained in a small area or a large area or somewhere in the middle? If your graph looked like, come over here for a second. If your graph looked like this, and all of your data was contained in this small area, we would say this had a very small distribution. If your graph, come over here again, looked like this, how do I do this? Kind of like that, we would say it had a little bit of a larger distribution. It's more spread out. So what do you think about this one? I would say it's probably moderate to large. Moderate to large. There's a bunch of data here and a bunch here, not so much here, here, or in the middle. So I would probably call this moderate distribution. So again, how many peaks? 2. Here's the sketch of it. I would say it's a little bit right skewed. It's almost symmetric, but probably a little bit right skewed. And I would say the variation is probably moderate. Let's look at number 8. That was number 7. Let's look at number 8. How are we doing on time? Go ahead and read through number 8. All right. The numbers of people whose street address ends in 0, 1, 2, 3, 4. What do you think about this? This is such a weird one, but I kind of like it. I don't know, right? This is what people usually say. I don't know. It's pretty random, right? We could have as many 10s as 20s, as 21s, as 1s. It's random. What they're trying to explain here is that it's random. We could have as many 0s as 1s, as 2s, as 7s, as 8s. So the graph would actually look like that, right? There's no way to predict 1s, 2s, or higher, right? There's no way to predict that at all. So the graph would just be a straight line. So how many peaks are there? 0, right? There's no peaks at all. And we can't really say there's 10 peaks. We couldn't be like 0, 1, 2, because there's nothing in the middle that's actually data, right? So that wouldn't work. So it has to be a straight line. Let me just draw it again. So there are 0 peaks. We already made the sketch of it. Do you think it's going to be symmetric, left skewed, or right skewed? Yeah, it's definitely symmetric, right? There's equal data all across the graph. And is the distribution small? Is it contained in a really small area, moderate, or large? It's contained in a large area, right? It covers this whole graph. So that distribution would be large. It's easy to get confused if you see like a graph that goes up really high and think that's large, but no, it's small. So this is large because it's spread across the entire graph. Good. You can try number 9 on your own. Feel free to send me a screenshot of number 9 and I'll check it for you. Pause the video now if you want to try it and I'll tell you what the answers probably are. I would say either 1 or 2 peaks and left skewed because mostly it's children and their youngish parents. You don't have a lot of grandparents. And I said a moderate distribution, but send me your photos if you want. What about number 10? I'm skipping number 10. What about number, which one do we want to do? Definitely number 11, 100% number 11. And I'm going to try to put this question on the test too. I need you to know how to calculate your GPA. This little thing on number 11 is straight from the SMCC handbook, which you can find online too. They want you to calculate your GPA for, where does it tell you the courses? Oh, at the bottom, right here. Compute the semester GPA of a student with grades, go like almost all the way to the bottom. With student of grades A- in a 3 credit class, a B+ in a 3 credit class, a C+ in a 4 credit class, a B in a 3 credit class, and a B-. So what I would do is I would write all those grades down first. They had an A-, they had a B+, a C+, they had a B and a B-. Right, but a 1 credit class is weighted once, and a 4 credit class it counts 4 times. So like this was a 3 credit class. This was 3, this was 4, this was 3, and this was 1. Fair enough. And an A-, it tells you, do they show you? No, they don't show you. Well, I'll show you up here. A 4.0 is an A, you already know that. An A- is a 3.67. A B+ is a 3.33. A B is a 3.0. You probably already know that. And then it's always 0.33 or 0.67. So the next lower one, right, is a B-. That's a 2.67. And then a C+ is a 2.33, and a C is a 2.0. And a C- is a 1.67. And a D+ is a 1.33. And a D is a 1. Okay, so those are all the numbers that go with the grades. So pause the video and copy that down if you want. I gotta erase it. So an A- we just said was 3.67. A B+ is 3.33. C+ is 2.33. A B is a 3.0, B- is a, wait, B-, yeah, 2.67. So I'm multiplying 3 times 3.67 and add that together. So I'll get a number. Then 3 times 3.33 should be 9.99, right? And add all of these numbers together. Go ahead and do it. So calculate all these numbers and then add this column together. Go ahead. Get my calculator. I thought I had this part done out, but I do not. 4 times 2.33, 9.32. And then up there, what'd you get? 11.01. All right, so when I add all of these together, I got 41.99. So I added these together and I got 41.99. Okay, then what do you do with that? What do you divide it by? You divide it by the total number of credits, which is 14. So I'm going to erase, but remember it's 41.99 divided by 14. We're still on number 11. 41.99 divided by 14. I think they call this quality points. Is that right? I think that's what they call it. This is how many points you earned but then you divide it by this so you can figure out what your GPA is. Hopefully you got a 2.83. That's what I got. But if not, try it. Let me see. Hold on. I had a different number one semester and then I corrected it. Oh, no, I got a 3.0. Just kidding. 2.999, right? 2.999, which is, we always round up to a 3.0. Good. So that's how you calculate your GPA for a semester. Might be useful. All right, let's turn the page and look at the graph. So now I'm on just figure 6.7 on the next page. We're still in 6.A. This is still part 2. They want you to draw a smooth curve which captures the graph's important features and then classify each distribution according to the number of peaks, symmetry, skewness, and variation. So I'll just show you what I did for the first one. Oh, this is so weird. So for the first one, I kind of drew the line like that, right? That captures the data. I said there are either 2 or 3 peaks, depending if you count that last little teeny tiny one or not. It's definitely left skewed, right? If you drew a line like right about here in the middle, most of the data is on the left-hand side. And I said the variation is very large because it's spread across most of the graph. This isn't large variation, right? Is not because it's high. It's just because the data is kind of spread across most of the graph. Let's check out the next one. Tornadoes by intensity. I didn't make that up, but I should have, right? There's one peak and it's right at the beginning. It's definitely left skewed. Most of the data is on the left-hand side. And I said there's moderate variation. Most of it's kind of on through about half the graph, and there's only a little tiny bit of data on the other half. Let's look at this one. I drew the curve that they want like that. I said there's one peak. It's pretty obvious, I think. It's pretty much symmetrical, right? This is about the middle, and about half the data is on that side, and about half the data is on that side. And I said there's moderate, I meant to write variation, not variability, moderate variation. And this one, I said no peaks. It's pretty much a straight line. This is like the door number, you know, one we did. No peaks, large. I don't know why I was writing variability. Variation, that should say. And it's symmetrical, right? If I drew a line in the middle, I would say about half the data is on each side. All right, that's it for 6A. I'll get the 6B video to you very shortly. Hope you guys are doing well.